I'm going to be honest with y'all. This video is a bit of a mess. It started because one of my favorite authors wrote a great blog post about co-location of data in your components and how React's data fetching model has gotten both messier and better. I ended up getting triggered pretty hard throughout, and the result was a diagram. A very good diagram that I put way too much time into. I think this diagram and how I explain it can clarify a lot of misconceptions that exist inside of how people think about React data fetching and the difference between fetch on render versus render as you fetch. If none of these terms make any sense to you, you should probably watch the whole video. If you just want to understand the different ways of data fetching in the React ecosystem and how to think about them, there will be a timestamp somewhere so you can skip to when I talk about this diagram. But yeah, this video is a crazy tangent of me writing code snippets, showcasing different behaviors, talking to this blog post and to a tweet about it. You're in for a ride. You can take the whole ride or you can skip to this part, whatever you prefer to do. I'm proud of this video. Hope you have a good time with it. Salute and good luck. Oh boy. So let's dive in. Also, the call out that Tanner Lindsley happened to make a thread on Twitter of like the exact same topic. We will certainly be going through this momentarily. But obviously, first and foremost, we need to read this. So let's do that. Recently, the React community went through a bit of drama. I'm not here to recite the whole saga in this blog, as this excellent chronicle by Dominic, aka TK Dodo, has already appeared. But here's a brief summary. Also, I have a whole video on this. Where is it? Here it is. Yeah, they searched the right things. How React 19 almost broke the web. Apparently, YouTube doesn't want to index this one because I talk about React too much. So I'll put this in the notes so you can more easily find it. It'll be in the description if you want to take a look at this video. It's my breakdown of the React suspense drama. Fun, big, dramatic one. Highly recommend watching. This is one of my best videos. I put way too much time into that one. It's not the usual I read a blog post thing, although there were blog posts in it. There's also a ton of behind the scenes work and research to make sure we characterize the situation properly. So check that out. It's way more important than this video. This one's going to be good too, though, so come back if you can. Anyways, previously, React on client would concurrently render all siblings under a suspense boundary and display the provided fallback element until all promises are resolved, kind of like a promise not all. The change behavior with React 19 would instead sequentially render siblings under the same suspense boundary on the client, which would allow for React to display the fallback element faster while introducing waterfalls for async tasks. It's like a for of instead. It might have been a trivial change from the core team's perspective, since the suspense behavior on client was still marked as experimental, but a lot of big libraries in the React ecosystem, including React Query, TRPC, and React 3 Fiber, were already depending on the original behavior, as well as many individual early adopters. So a big pushback was inevitable. I don't fully agree here. Of these libraries, TRPC wasn't directly using this. It was part of React Query using it, because TRPC is just a shim on React Query for its React bindings. So anything TRPC is doing in React is almost certainly React Query. To be fair, the TRPC devs do make requests and do file PRs to React Query to add functionality for TRPC and other things like it. But TRPC isn't using React Core so much as they're using React Query so heavily. And they're one of the few consumers that's heavily using the suspense stuff, which, by the way, most people using React Query have probably never written a suspense query. You know what? We're going to poll. If you're not a React Query user, first one. If you are a React Query user, but you've never used suspense query, you just use query, this one. And then yes, if you've actually used a suspense query before. Yeah, this is what I thought. 50% not using React Query. Fix that. 50-ish% using React Query, not using suspense query, and only 2 people in my audience, admittedly pretty late, we only got around 300 people still watching, only 2 rushed to go click yes, they've used use suspense query. So to the point of the article, yes, React Query does technically take advantage of this suspense behavior, but not a very large percentage of React Query users are actually taking advantage of that behavior. So yes, it sucks in the sense that a big library had some things that got worse. But the point I want to emphasize is that React was thinking about the users building apps with React with a change like this. Because for most apps, especially apps that are big like Facebook, the change to get you the fallback earlier was a good change. Watch my video if you want a breakdown on this, but the point I'm trying to make is that very few people have actually used suspense in the way that React broke. Just because the library supports it doesn't mean the users are using it that way. There is an exception though, React 3 Fiber, which absolutely uses this very heavily. React 3 Fiber was the real victim of those changes. Anyways, I've made my point. You saw the poll. I'm right. Let's continue. A big pushback was inevitable. Absolutely. This all shortly concluded with the React team reverting the change, acknowledging the concerns, and promising a better alternative in the future. Again, React team were bros here. They recognize they fucked up. They've been holding the React 19 release for months now on this. React 19 would have already shipped if it wasn't for the fact they're spending all the time doing this. What most stood out to me from the discussion, however, was the core team's early response to the community feedback. Initiating data fetching in individual components under a suspense boundary, a pattern known as fetch on render, is a bad practice. This is the important key here. Fetch on render is a thing that they want to discourage. What does that mean? Let's come up with a mock example. Let's take this example of a friends list component. Let me export this so it gets a little happier. We have a data error in loading, and we're hitting this API endpoint API/friends. Let's say that instead of this returning a whole friend object, it actually returns all of their IDs. Now let's make a friend component. So function friend item. This takes in props ID string, and we want to get the rest of this friend's info. Look at that. Cursor's getting pretty smart. So we have this use API call where we're calling API friends friend user ID. Now we're getting back the data, and we can use this for something. Let's just render data.name. So now we're rendering their name when we get it. And we can go over this list. I'll just leave that as div for now. Look at that autocomplete being so smart. So we got our data, which is the array of user IDs, and we map over it. And for each one, we set the key to be their ID as well as, importantly, the ID that we actually pass. So the thing to note here, the part that matters, the reason everybody's upset, is the concept of fetching on render. So the thing here that sucks is that we have to load all of the JavaScript on the client, render this component, and then, and only then, can we start fetching this data. If we want to get all of the user's friends, we have to wait till the site has loaded, the JavaScript's loaded and been parsed, it has rendered, and it has put out its first response. Then this use API call fires, we start getting that data, and then we re-render when we get it. That seems pretty bad. Where it gets way worse is the waterfall, because once this back and forth is done, so we have the first back and forth where we go to the server to get the HTML, then we have to go to a different server to get the JS, then we have to load the JS, then we have to render the JS, then we can start the first data fetch. Then we get back the data, we render all of these additional components with all the friend items, and then each of those now has to make its own request. That sucks. Now we have so many back and forths before the page can actually render the content it's supposed to. That's the issue. When people talk about fetch while rendering, this is what they're referring to, is in order for the fetch to start, you have to render the component first. And this is inherently likely to cause waterfalls where you have to load data to then trigger the next load, to then trigger the next load, because that's architecturally what fetch while rendering is you have to render, then fetch based on the render. There is a beauty to this way of writing, though. The cool thing with this is now I can mount friends list anywhere, and I don't have to give it props, and it will just render. It will just work. And that piece of React is magic. The composition of friends list guaranteed can figure everything else out that it needs to do. That's a really, really cool thing. But this comes at the cost of you can't optimize the data loading, which means getting the data to this component to then render is slow. There are solutions to this. Things like Remix, which pushes you to move the data loaders out of React into the routes and then pass the data through so the data loading can start before the components actually render. This is a bad example, though. Why wouldn't the fetch with the list give you all the details you actually need? Because React devs aren't backend devs. This is hilariously common that the backend team doesn't give you the flushed out friend object you want with the API call, and you have to make a separate API call to get the actual data. But this is super common to have something you're fetching from that loads identifying data or an array of the pieces, but doesn't give you everything you need. If your front-end team has that level of control of your backend where you can always write the exact right thing at the right time, that's awesome. But most front-end devs are strapping together 15 APIs from 50 different teams, none of which return what they're supposed to. And this is how they've solved that problem, by just fetching all over the place. It's the harsh reality of working in technologies where your backend and front-end are so far abstracted and the teams don't even talk to each other. So as much as this is a bad example in the sense you shouldn't do it this way, It's a realistic one. Emily points out that the opposite is true too. She writes an API to give them all the data they need, and then they ask for simpler ones that only give one piece instead. Great question. How do we fix it if we don't have control over the backend? We'll probably get there as we go throughout this. Let's keep reading this article because it's almost certainly going to be very good. Initiating data fetching in individual components under a suspense boundary, which is a pattern known as fetch on render, is bad practice. The recommended alternative was to prefetch data outside the components that read the data. But wait, isn't React all about composing components? Components that contain everything they need, state, logic, and view, all nicely co-located. Are components not sufficient? Ooh boy, I like this framing a lot actually. Components, a success story. One fundamental bet of React is that components are a primary building block for UI apps. Each component contains a full recipe for React to produce a piece of UI, state, logic, and view. A component may include other components as its children, thus forming a tree. So a React app is the root component of a component tree that is passed to React to render. On state change, React re-executes the whole or parts of the component tree to produce the latest view. Of course, the actual process involves a few more steps, but that's the gist of it. This has turned out to be a wildly successful bet. For years, React has reigned supreme in the web UI development space and gained significant traction in the mobile development space as well. There have been many alternatives, some of which have found great success as well, but React still largely dictates key conventions and concepts in the space. Indeed, most React alternatives are component-based, even if they may differ in the details on how components work. In fact, the idea of component has been so successful that React is bringing components to the other side of the network. We now have React on the server, or as I'd like to call it, React server, that understands components, produces an intermediary React tree representation, and sends it over the wire. React on client then weaves the server output and its own component tree together in a single React tree to finally update the UI on the screen. It does, and it does this in a way that's really fucking cool. I also got another idea for a video as I was reading about React Native. The secret sauce that makes React Native magical. Alt title, why we'll never see another React Native. I have so much to say about React Native. Let me know in the comments or chat now if you want to hear what I have to say about that, because React Native does not get enough credit for the cool things it does. Anyways, the trouble with state. Unfortunately, React components fall short as a sole model for the real-world apps. One main challenge has to do with state, or more precisely, the high cost of shared state across the component tree. The React model executes components to produce the latest view on state change, and this puts a lot of strain on performance for a large tree that includes computationally expensive components. This is exacerbated by state that sits close to the root of the component tree and is used broadly across the tree, because any update to it can lead to a huge amount of work, regardless of how small the actual diff might be. Very fair points here. Seeing this a lot with people putting a giant context at the top of their app and then actually changing things over and over again. It's obnoxious and a very real performance problem I've seen. I will say a lot of the changes in React have allowed us to work past that in solutions like Zustand and Jodi, pulling the state updates away from the global and away from a root context so that you can trigger them more granularly, has let us work through most of that while still maintaining the tree nature of the React component hierarchy. But it's a fair point. Another important and related challenge is data fetching. A component tree in which individual components fetch data to satisfy their own data requirements can lead to a waterfall of network requests as well as poor user experience. This problem is made worse when data requirements for one component depend on another's, further degrading the user experience. As they said, the problem is made worse when one component's data requirements are necessary for another's. As I showed before in the code, this component has to fetch this data before this component can fetch its data. Another common one, to give a better example, would be here we fetch the user's data. So we use the cookie to figure out your user and your user ID. And then we pass the user ID to the next query to then fetch your friends list that has everything in it. Waterfalls are almost inevitable when you're building things this way. The community has recognized these challenges and made numerous attempts to address them, some more successful than others. Facebook engineers, the largest React user since its introduction, proposed Flux as an architectural solution in which React was playing only a part. For more concrete solutions, we have seen Redux and many other state management solutions, React Query and other data fetching solutions, Relay's compilation of multiple GraphQL fragments combining into a single query, React Router and Remix's nested routes and parallel data loading patterns. The list goes on. Relay is particularly interesting here because it goes through your component tree and sees which GraphQL chunks each component requests, and then it composes that into a single query that I could fire all at once to get all of the page's data in one request. It's a really interesting solution, and it's a big part of how Facebook functions. In all of these, we repeatedly find a common pattern where we need more than a single component tree to build an app with React. We need managed state placed outside of the component tree. Of course, the managed state still needs to be accessible from the component tree, and the main mechanism for this is using a context and hooks for individual components to access managed state and data. And there we have the common structure of a React app over the last several years, always buttressed by the ecosystem. That's a word I've never seen before. Welcome to the jungle. You wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. This is a famous quote of Joe Armstrong, a co-creator of the Erlang programming language. In the original context, the quote was an analogy to describe the problem of implicit environments in object-oriented languages. Oof. I don't like that you're applying mocking OO to React right now, but I'll take it, Boba. It may be a surprise to some, but the same applies to React as well. A common practice, a temptation even, is to put everything a component needs to produce the UI inside of its body, making it appear as an autonomous, self-contained Lego block to compose with. There's even a name for this, state collocation. The general idea is to keep state as close to where it's used as possible. This mostly works when all necessary state is strictly local to the component or it's provided as a prop. But as we've discussed earlier, passing external state to components as props can get very expensive in React. An entire ecosystem has been built around addressing this. A natural workaround to this conundrum is to place state in a context and have components to access it via hooks. This allows React to re-render only the relevant components on state change instead of the larger component subtree. Indeed, this is how many established solutions are handling state. Place our context provider at the top of the component tree and access managed state directly from your components via hooks like useSelector, useQuery, useLoaderData, etc. The not-so-hidden cost of this performance optimization is that your components are now tightly coupled to these Gorilla contexts. I have feelings, but I want to keep reading first. So now we've arrived at the jungle. We wanted simple components to compose with, but what we got is components that are tightly coupled to global state and context as well as other dependencies. So now we've arrived at the jungle. We wanted simple components to compose with, but what we got is components tightly coupled to global state and contexts as well as other dependencies. The irony is that the more we try to make our components autonomous and self-sufficient by co-locating all their state and data next to the UI, the less composable they actually become. Oof, that's a banger. Funny how components come so close to objects, state location to encapsulation, and context and props to dependency injection. They may as well be the same thing. Oh boy, what's this tweet? Components are objects. Components equal local state plus methods. Local state plus methods equal objects. This is funny. This is from 2017. This is like before hooks even happened. I think the component object distinction serves to culturally distinguish JavaScript and Java. Quote, we do not do OO like that. Okay, I don't fully agree with this point, actually. I know Elm is trying to do functional programming even further, but the mindset for React and the thing that the React team's always pushed is UI equals F of state. The goal is that you have the function, which is the React app, and you hand it a state, which is the way the world works, and out comes your UI. That was always the goal of what they were building with React, and it has had crazy paths to and from that point, but that was always the goal. I know that Dan changed it very slightly. So instead of UI is function of state, he changed it to UI is function of data, comma state, because the data is the thing that loads in first, and then state is the things that the component and the UI owns. So it's two layers of state, so to speak. The client UI paradigm is UI is a function of state, which is how you write a counter. The server UI is a function of data, which is how you would do something like a post preview for a blog post to preview the contents of a given blog. These are two entirely different paradigms, but when combined, you can do really magical things. And it does still feel in a lot of ways like our UI is the result of these inputs. And yes, once you start intermingling and mixing and having components, which are UI, determine their own state, it gets more complex. But that's part of why React is pushing back on the fetch while render patterns and pushing us towards these higher level data loading solutions. Components are pure overhead. Many of us have learned to live in the component jungle. Some may even enjoy it for fun and games, but others are desperate to find a way out. What are the alternatives? Solid, the poster child for signals, mostly bypasses the problem of state view duality by treating view as a mere byproduct. This is a very interesting point because, funny enough, we were working more on Solid recently for the upload thing bindings. And of the new frameworks, it is the one that is like the easiest to pick up as a React dev by quite a bit. But it's still very unintuitive that the contents of a given component don't rerun when a change occurs. Because instead of having a tree of components that trigger updates where a parent component makes a change and then everything underneath it updates accordingly, the tree isn't of your components. The tree in Solid is of the data and the signals, because you don't even technically have a component, as chat corrected me. It's technically a setup function. It returns JSX, and it can call other setup functions that return more JSX. But if you want your HTML tree to be able to update, you have to build a hierarchy with your data separate from the hierarchy of your UI. Part of the magic of React is that you can roughly keep track of the state hierarchy by using inspect element. The fact that if I inspect element, I have this hierarchy of HTML that roughly maps to the hierarchy of my React code, and I have things like the React debug tools that give you an even deeper way to look in like that. It makes visualizing and identifying where your state is going significantly easier than something like Solid, where that's your problem now. So yes, React is kind of forcing us to do our state in a specific way that might not be optimal in many cases, but it's good enough in most of them, and it's way easier to visualize and debug. And I've regularly found that trying to figure out what's wrong in a signal-based approach is a lot harder than figuring out what's wrong in a React-based approach. I'm obviously very biased because I've debugged a hell of a lot more React code than signals code, but it has been quite hard for me to debug the weird, even small signals problems that we have relative to doing things in a component hierarchy. As Boba says, the truth lives in the signals graph holding state. The signals are where the UI update graph comes from, not the components themselves. All components in Solid melt into air after completing the job of setting up the signals graph. In fact, Solid's creator Ryan Carniato already declared that the future is componentless as early as in 2021. And we're seeing his prophecy may be coming true as more UI frameworks are moving away from components in runtime, like Svelte 5 with runes, Vue Vapor, etc. HTMX's locality of behavior principle offers an alternative take on what made components successful. The intuition of what changes together should be placed together. I do love this. The thing that exists and the ways that it change should ideally be as close to each other as possible because it makes reasoning about your code base significantly easier. But of course, there is no real component to speak of in HTMX. All there is are a handful of these HX attributes to encode behaviors into the HTML elements, and a few tricks like boosting. And what about state? It mostly just lives on the server side, unbeknownst to the client side that receives the resulting view over the wire. This is a limitation that is also a blessing to many who got burned by juggling duplicated state on both ends of the network. This is a very real problem. Once you had to deal with client and server side state and balancing the two and making sure they were all correct, it's hell. And we're starting to get into this again with the current local first movement. People are going to get crazy here. Worth noting that state takes priority over view in either approach. Also a fair point. Yar VTW, yet another React versus the world. Back to the recent drama. What it highlights is the gap between React's component-oriented vision for building apps and the reality of its current limitations, as well as the established solutions from the community to address those limitations. Until recently, React and its community partners were largely aligned, but the relationship is starting to evolve as React's own vision and scope expand. By bringing components to server, React takes another shot at putting both state and view under the same component model. Yes, there are still two separate structures, but they're both component trees that React can manage, and here it goes, compose. Yes, this is basically the conclusion I was going to come to, which is a lot of the templating and a lot of the setup stuff that shouldn't be part of the React tree often still requires data, and either way should probably be run first on the server, be it during build or when the actual page is requested. And the more we can move to that and let the components be these small optimized solutions in their tiny little boxes, we get really close to the vision that even somebody like Alex Russell had for the web of a static page with little interactive elements. And we're getting there. Every framework's becoming a crab. And by a crab, I mean a bunch of little JS bundles inside of a giant application. Along with that, React aims to establish new patterns for architecting apps where the component tree on the server takes on the responsibility of keeping the current view in sync with server state and data. In turn, the component tree on client gets new features like use optimistic, use action state, use form status, and more to streamline passing messages to and from its server counterpart. In the new React architecture, perhaps React alone is sufficient to implement the flux pattern across the network gap. And is it just a coincidence that React now has an action in its core terminology? I'm just asking questions here. The client tree getting leaner and lighter is a bonus, and the React compiler can make it run even faster. Maybe we even mentioned compiler here because it solves a lot of the update problems. Good call out at the end there, though. And remember, we are getting to the end, but I still have to read the Tanner thing too, so don't leave just yet. As it pursues this RSC strategy in full force, React now makes a new demand from the ecosystem where frameworks take a more central role. And with that shift of focus, frictions are inevitable. All established solutions from the community have invested a lot of time and energy, but now we'll face an uncertain future. So the latest drama is only one manifestation of the friction. I expect more to come. I don't really agree here because the friction was brief, agreed upon, hurt a very, very small subset of React users, and it was fixed. So I don't think React will have this problem. Historically, React's backwards compatibility has been insane, like unbelievably so. It would be hard for me to believe that someday there's a React 20 that React 18 users can't reasonably upgrade to. While I agree React won't back down on their vision, they will absolutely find a way to minimize what breaks in the process. Will friends turn enemies, or will their bonds go stronger after tests and trials? All eyes are on React. At least we agree here. Everybody's following React and what it does and what it learns. Let's hop to this Tanner thread. But first, huge shout out to Boba. I'll be sure to link his Twitter in the description so you can follow him. Let's hear what Tanner has to say. Very curious. I'm very thankful React rolled back the v19 suspense gate and were willing to work with us. I think the future's as bright as ever. Now this is where I want to go next. I'm increasingly concerned how much React is pushing render as you fetch, hoisting and preloading as the blessed and last week almost required approach for client-side data fetching, despite the current state of the ecosystem. This is a fair point that right now, most React apps are fetch on render, not render as you fetch. And that's going to be hard for a lot of companies to adopt. Even the ones using GraphQL are often doing it through something like Apollo, which is very much fetch while render. So flipping it so that we start fetching immediately and then UI appears as the data appears, instead of the UI appearing, then triggering the data to then appear. That's going to be a hard move for the whole ecosystem. Not in like the tools like the libraries we use, but the big code base is built that old way. Regardless of the library you use to fetch client-side data, if you're not using a framework's SSR level route loader or async paradigms, your solution probably resembles some kind of hook, like useQuery, or heaven forbid, one that you rolled your own. Tanner is one of the few people that can make that joke as the creator of React Query. I'm happy about the concern we all have for performance, UX parallelism, etc., but not super happy that some of us are so quick to give up the amazing DX that is data colocation. Woof. Very real. Every once in a while when I'm building an app that's interactive enough, I desperately miss React Query and tRPC and then cave and do it. I just got mostly done with rewriting pick.ping, which is the tool I use for managing my thumbnail faces. This will be open soon for people to pay a subscription and use their own picture management. Very excited for it. Previously, I did this all using server components, and I started running into a few annoying things to do. Things like infinite scroll with pagination. You can't see because I have the stupid Vercel bar there, but when I get rid of it, you'll see these little scroll wheels appear as you get to the bottom, and the rest all floods in. Doing those types of things was a little bit annoying with server components. There wasn't really a pattern for it yet, but it's just built into React Query and tRPC. It was like 3 lines of code to do that with this instead. So I started moving more and more of the API layer back to that solution because just embedding the data call in the component and using those existing libraries and their existing behaviors made building a real usable application way easier, even if the first load now takes slightly longer the first time. It's worth it, especially because I'm going to start locally caching some of these responses so that you don't have to load it from the server to do the stuff on the client. As far as I know, Relay is one of the few libraries that can really handle hoisting data requirements out of components automatically, not without a lot of buy-in and convention though, and it gets you the best of both worlds. It's naturally that RSC is the spiritual evolution of this pattern. I've talked about this a little bit in other videos. I don't think people understand how much Relay influenced this new direction with RSC. I should do a deep dive on why Relay is so cool at some point. Let me know in the comments if you want to see that. The quick TLDR, as I was mentioning before, is that each component can write a GraphQL stub, and then your compiler per route goes through and finds all of the stubs all the components need, and then generates a single query to fire for the whole page. That pattern's magic because you're writing the query inside of the component, but the component isn't loading the data. The component is adding to the request for the whole route, saying, hey, to render me, I need this little bit. And then when the page starts loading, it can load that data before the component is even rendered. This influenced the way that server components were built massively. Just one example is the way that server actions work. If you have a bunch of components that use actions, even if you import an action that's not being used anywhere, just importing it on a given route means it's now part of that route. Because again, the goal of a lot of what's going on here is to make it so that your routes know what behaviors each component might need so it can get them ready way further ahead of time. So basically, is getting back to waiting for the whole page for data to load before you see any? No, it's render as you fetch is the pattern. So fetch while render is you have to render, then fetch. Render as you fetch means when things come in, you can render. And with relay, you can have certain things delayed. You can say this can be deferred. I don't need this immediately. And then other things come in as fast as possible. And then you can render as soon as all of the requirements for a given component are met. That component can render, and then other components can wait until their requirements are met. People seem confused about render when you fetch versus fetch while render. Let's Excalidraw a bit. So fetch and render. And I wanted to break it down a bit. So let's say we have this component hierarchy. We have the app shell, which has the top nav. It needs to know who the user is to know what to render. If there's no user, it needs to render a signed out view, which is fundamentally different. So this has to have the user info before anything else can render. I show that by binding this green arrow here, because app shell needs user info from this API blob. This is meant to show all the things that this page needs to load. So app shell needs user info. Friends list needs the friends list, which only returns the IDs of your friends for some reason. And then the actual friends in the friends list need to have the individual friend data, which eventually will be an array of all of your friends. So if this is the UI you want to render, and we render this the fetch on render way, I made a nice diagram. I've been working on this for the last 20 to 30 minutes. Shout out to my editor for turning this into a video. Everybody give Faye some love in the comments. He deserves it for this one. Anyways, if we were to use the fetch on render pattern, which is how most React sites work, first step is the client requests the HTML. It then parses the HTML, sees that there's a script tag in it. Then it goes and fetches that JavaScript. Then the JavaScript comes in and renders the components, but it realizes to render that first component, to render the app shell, it needs user info. So before it can render anything else, it requests to the server, says, hey, I need user info. So it identifies the user, probably using cookies. Then it goes and generates the user info response, and then it sends that to you. Now the client has it. It can finish the app shell, but now it starts rendering the friends list. And it realizes it needs more data. So it goes over the wire again and says to the server, hey, I actually need the whole friends list too. So it has to re-identify you because it's possible that your authentication has changed or that you're making this request in an illegal or fake way. So you have to be re-authenticated and identified. Then it can do the friends list. And then we send you that. And you're like, oh, but I have to render all my individual friends. I need more data for that. So we have to re-identify you, fetch the individual friend endpoint, and then finally send you that so you can finish render. Notice how long that is. And that's a pretty simple example, and it really showcases the waterfalls. The first waterfall is when we wait for the JS to load. Then we render the first component that requires more user info. Then we render the second component that requires more info. Then we render the third component that requires more info. So it's step by step by step until you finally get to the end. The reason render while fetching is interesting is because instead of the client side determining when data is fetched, the server side determines when the components render. So instead of the client rendering a thing and then pointing at the server saying, hey, I need this data, and doing that multiple times, it goes the opposite way. Where here, we have the user fetching the HTML. Since it's hitting an endpoint to do that, at the same time we respond with your HTML, we can kick off all the stuff we need to do on server and then stream in the responses. So think of this more like once you request the HTML, the server then starts doing everything that it can and then sending it over when it's ready. So at the same time you are parsing your HTML, fetching the JS, and doing all of that, we just wait for the data. So you can, at the same time that you're loading the JS, loading your fonts, loading your CSS, loading all of the things your site needs to run, we can be identifying you and generating your API responses in parallel. And then when these things are ready, which by the way, we only have to identify you once because we're doing all of the rest of the stuff after that identification. So we identify you, we start in parallel fetching your information for the shell as well as your friends list because we know you need both of these things on this page. And we send you both when they're ready. We send you your user info when it's ready. Now you can render the app shell. And then we send you the individual friends list when that's ready too. If we're being honest about how fast this is, like relatively speaking, this is like here, and then this is probably like overlapping, happening at roughly the same time. And that's The real magic of render as you fetch is the fetching isn't happening because a component asked for it to. The fetching is happening because by opening the page, the server now knows to start generating this data to send to you. So render while fetch is when the server is done fetching a given thing, it then tells you to render. Fetch on render is you render and that triggers a fetch, and you do that over and over. It's on this pattern, I'll rename these render triggers fetch versus fetch triggers render. And that's the difference. In this model, rendering triggers the user to fetch from the server. In this model, loading the page triggers the server to start generating the content, and then when it's ready, the content renders. And hopefully, the difference in the height of these trees highlights why both the React team and the general web ecosystem are pushing us in this direction, because it takes 1/3 to 100th as much time to do. This is an obviously better solution, and I hope this helps clarify why the React ecosystem wants us here, even if a lot of React apps in reality live here. That was quite a tangent. That might even be worth doing a separate video of. You could argue that a loader with a loader lifecycle solves a lot of this. But one, this assumes that your data usage site is close to your route boundary, and if it's not, then two, you likely had to either move the data out of a deeper component that uses it and into the loader, then pass it back via props. Yeah, getting these patterns working with existing React models is not fun. Like, how do you figure out what data each component needs, and how do you actually get it to the components? Co-location, on the other hand, feels natural for projects that require this level of data dynamic behavior in components, like a dashboard widget or a productivity app. And for the most part, it works amazing, unless you need SSR. And that's where I imagine React has likely been thinking that server components would fill in nicely. As always, SSR is the crux of it all, and Relay was onto something. Regardless, if you need both co-location and SSR, you have to jump through hoops to get there. Annoying ones. Even with those annoyances, though, it's hard for me to imagine many of these highly dynamic apps moving to an RSC future, unless they have SEO and SSR stuff that they're required to do. It's the bread and butter of your product. Like if you're a social network or e-commerce, you have to do it. My point is that RSCs are not the only answer to co-located data fetching, and honestly, they still require some kind of hoisting conventions if you want to avoid server-side waterfalls. Server-side waterfalls are a significantly less big deal. As I showed in my diagram here, you'll notice on the server-side waterfall, so to speak, we only had to identify the user once. And we could still do these two things in parallel and then do this third thing after this one without having to re-identify. That's a huge win. Not having to wait till the client hits the server, re-identifies the user, figures out what they want, connects the database, generates it, and responds. Doing that in one request is exponentially better, even if you're firing the same number of database queries. Yeah, so that's the one thing I'd push back on is server-side waterfalls are nowhere near as big of a deal as client-side ones. And I hope the diagram helps showcase why. For starters, RSC requires architecture and opinion buy-in beyond just npm install React. Yes, the architecture you have to adopt to use these things is the biggest complexity and the reason that they're not just immediately taking over. So when I see render as you fetch, what I really see is a hefty checklist. Data hoisting with a compiler, router conventions, etc., cache coordinator in order to make sure the right data goes to the right place, as well as a consumer to make sure you have a good way to actually consume that data. And there's also a whole bunch of hairy code to make sure the SSR is actually working with streaming, hydration, etc. It can be more performant for some KPIs, and if you need those or SSR, you'll have to do it anyways. But it would be a mistake to think everyone's in that bucket. I would really like to see more attention going towards retaining the awesome DX of being able to co-locate data requirements with usage sites without forcing more cognitive load around prefetching patterns. I don't know what those solutions are yet. I have ideas. But even if we, as an ecosystem, were to go down that road, it would be 1,000 times better if it was a problem React itself would consider as first class, instead of some cursed pattern that needs to be squashed or discouraged. That's why TanStack Query is so awesome. Yes, there's some extra preloading to do if you need SSR, and for RSCs and frameworks, we've already been hard at work for some pretty cool stuff, despite not having primitives in React for it, in order to make it just work with RSCs. TanStack Start and Router will be no different. Reducing cognitive load is our goal, and trying to remember if you preloaded or kicked off a fetch in a loader is high on my list of mental tasks to destroy. Please don't kill co-location. In the end, we're all reinventing Relay, aren't we? This is a great perspective. Huge shout out to Tanner for continuing to fight for the client-side data fetching and for the co-location experience. At the same time, there's a reason that we're being pushed this way. If you can do this, it is not a little better, it's exponentially better, and it solves most of the problems people bitch about with React. The issue is, how do we solve the things people bitch about in React without making it not feel like React that we love and care about. We're all here because we love React. A part of why this is happening is people who hate React will have less reason to. But in the end, we're all doing this because we love the DX we have and we want to keep pushing it forward. Shout out to Boba for writing the article. His link will be in the description. Give him a follow if you haven't. Let me know what you think, and please watch and share this video so the diagram I just spent far too long on is worth it. Till next time, keep fetching.